Hello, welcome to this session where we're going to talk about AutoML. I call it the machine learning hero's secret weapon. I'm not sure if that's a secret anymore, but I am sure it's a nice weapon to have in the arsenal of the tools that we have. So, yeah, before we talk about it, let me kind of introduce myself for like 5 seconds. I'm Daron Yondem. Yeah, this is a website where you can go and check out who I am about and who I do, what I do. And then there's a Twitter alias that I wanted to share, and that's going to be at the end of the slide deck as well, in case you have any questions. We are going to have some time at the end of this session for Q&A. But in case you have follow-up questions or things that come to your mind after you're done with the session, you just you jump into another one or anything like that, right? If anything comes to your mind, feel free to get in touch with me on Twitter. And you might find some value with the stuff that I share on Twitter as well. So in that case, you might want to follow me up on that one. Anyway, so that's enough with the advertisements. And let's jump into it. So, what is AutoML? So, first off, let's a little bit talk about it and do some reading because I got some nice notes in this slide deck here. So, automated machine learning, it is what it is essentially the process of automating the end-to-end process of applying machine learning and experimenting with machine learning to create, develop, and deploy predictive models so that any enterprise benefits from data. So that's important. So as you can kind of imagine at this point, these are all stuff that we can already do, like, create, develop, and deploy predictive models. Yes, we can definitely do that. But we're going to talk about this, but there's a lot of manual work and experimentation that needs to happen during this process so that you can really find the best route or the best model, for example. And automated machine learning is really there to help us out. I mean, at the end of the day, it's some automation that relies on, that kind of tries to automate what we do. So we are automating a bunch of work that we do when we're building machine learning models. That's the whole topic, and we are having the machine do those experimentations for us. And we'll talk about this, but the whole idea is that there's this low code or no code experience. So I'm not going to say you don't have to have any data science or machine learning or AI know-how. That would definitely help out. And you're going to see when we do demos, you're going to see that some of the, stuff, we're not going to be able to go very deep. Obviously, this session is about AutoML, not necessarily ML, but some knowledge of ML will definitely be helpful. But on the other hand, we're going to have a lot of automation as well. So again, low code, no code experience pretty much, helps us accomplish something, create some insights out of the data that we have without writing any code. So that's kind of one of the goals. And then finally, keep searching for the algorithm and hyperparameters based on the metrics you define. Yes, I mean, that's what we do. And the metrics are going to change. We'll talk about that. But, long story short, what AutoML does, it keeps searching for the best algorithms by fine-tuning or picking different algorithms and fine-tuning the hyperparameters for you. I can actually call this pretty much a brute force approach, not necessarily a fully brute force, but kind of close to it within the confines that we kind of limit. But at the end of the day, this is, I mean, to me at least, it's kind of brute force approach into machine learning where we, you have this, X amount of compute resources that you can use to run experiments, and you're then defining the confines of your parameters or the algorithms you want to test out maybe, and then you're giving it to the machine to just keep doing its thing, keep running it. And obviously the parameters that you define is more like, this is the amount of time that you're going to have in the confines, right, of the experiments, of the full experiments. And we'll talk about this, but overall, this is what AutoML is about. So that was a short break, an early one. Okay, here we go. So the process, let's talk through this. So we can have, the data sources. We do have data sources, right? I mean, the data sources can be a SQL database, a Cosmos DB database, a data warehouse, maybe data lake, blob search, or whatever. So you usually get the data from there, and then you start preparing the data. You clean it up, you prepare it, you try to make sense of it a little bit. At times, maybe you're gonna need to add some additional data and a little bit of a noise if you're really worried about, I mean, that's a totally different topic, but fair AI type of thing. So, anyways, so you got the data and you got the preparation step, and then you build and train a model, right, that you hope is going to be the answer to all of your solutions. And that process within itself has a lot of recursive experimentation. But then once you have your model, then you gotta deploy it somewhere so that you can serve it to the outside world, right? Either those are going to be mobile apps that are going to be using it or whatever. So these applications should be able to come into the model and do predictions. So that's kind of the high level process. And the problem is, in this case, we're going to go with a very simple sample problem. How much is this car worth, right? I mean, that's kind of, we start with a question when we start with the ML process. We have a question that we want to answer or predict, right? So in this case, this is our question: how much is this car worth? So then we start digging into the data that we have, and kind of we try to understand, hey, which features are really related to this question, which features do affect our prediction capability, and then which algorithm is the best for this type of question, which algorithm gives us the best answers, and then which parameters. I mean, fine-tuning these parameters and trying to understand. And this whole process does, for example, at the end of the first iteration, maybe you got a 30% successful model, and that's most probably not enough for you. So then you're going to iterate. You're going to change maybe the features. You're going to add new features if you have that data, or sometimes you're going to remove features, and you're going to pick different algorithms. You're going to fine tune your parameters, and this takes a lot of time. And this is what AutoML is trying to automate. Because first off, I mean, so far I did talk about, this takes a lot of time, we got to automate this. But on the other hand, there's this thing that you might not know what to do, and this, on this level. So you might not know really, you might not have the experience to fine tune all of these parameters. You might not know that, you might not have the experience, you might not have the team in the organization. So in that case, AutoML isn't just an automation tool. It actually helps you get something out of your data, right? So that's really helpful on that front as well. It's really hot. It's summer hot in here. Anyways, even though I have the air conditioner, I don't know, for some reason. Okay, here's a slide that I'm not going to talk about. This is just a show off slide to scare you off. Like, this is the complexity. And this is actually a piece of the complexity that we're talking about. And yeah, I mean, this is what you're going to be playing with if you want to do this manually. And it's not a bad thing, by the way. I'm not saying, hey, this is too complex, you shouldn't do this. No, I mean, if you have the team, the people, or the knowledge to dig into this, and this is helpful, by the way. If you know all of this, if this all makes sense to you, it's going to be really helpful when you do AutoML as well, because your experimentations will be more fine-tuned, if that makes sense. Maybe you're gonna use less resources during your AutoML process. But if you don't know, it's gonna cost you a little bit more, maybe because you're gonna need to do more experimentation within the AutoML process. But again, just to understand, I mean, this is the level of complexity, and it can actually get more complexer than this. Okay, so the model selection and hyperparameter tuning is the thing. So we are kind of talking about that for the last two slides, but you got the data set, you got the training algorithm, and multiple. I'm not sure if this is clearly visible on this diagram, but there's two training algorithms. So you got the data set, you do the model training and rejection, and you export a model, you test it out, you train it with another algorithm. You have a set of hyperparameter values, different configurations based on those, and you kind of mix and match. Right. Again, the level you're gonna mix and match might depend to might be decreased based on your know-how, but you can go with a full brute force approach as well if you don't really have the experience, and that's fine. That's fine. But the thing is, we did talk about that, like the parameters are going to change, right? From a high level perspective, the parameters that you feed into the system, in this case, those are hyperparameters, the selection of the algorithms, and the features. So those three input will change into something else when we start talking about AutoML. And yeah, this process is repetitive and manual. But then when we go into AutoML, these parameters are changing, and you can see that we got optimization metrics and we got constraints. So we still have the data set. Obviously, we still need the data set. But when we go into automated ML, we got optimization metrics. We can decide, hey, I don't want this algorithm. I'm sure it's not going to work. So let's leave those out of the full experimentation cycle. And then we got constraints, which is time and cost, because you are telling the computer, right, to you are giving it a set of algorithms, and you're telling the computer, hey, go and try on as X amount of time as possible within the constraints of, you got 5 hours, or you got 2 days, you got 10 days to go experiment, run with different configs, and get me the best setup, right? Try to see if you can get better predictions with different configuration values, and keep doing that within this time and cost constraint. And out of that, give me a report and let me see which one of these experiments did get the best results, so that I can pick that and continue. So yeah, and optimization metrics here is what you can play with. And that's the area where, if you have machine learning experience, and what all these algorithms and hyperparameters and all that stuff does, that's the optimization metrics section is where you can create that personal contribution by defining those confines that I mentioned for the full set of experiments that you're going to run. And obviously that's going to help with the time and cost as well. But overall, as you can see, when we look at the previous slide, the algorithm selection, the hyperparameter value configuration, and all that, they do not exist in here, right? So yeah. So at the end of the day, it is a little bit arguable if it's faster or not. I think it is. Yeah, it might be faster. Yes, because it's automated. It is definitely more accessible. That's for sure. Okay. So, how to use AutoML in Azure? Sorry about that. How to use AutoML in Azure. So we got two options. The first one, I know I mentioned no code experience. That's definitely available. You can see that on the second line item. Give me a moment. Okay. I don't know what's going on. Anyways, so the first option is the codified option, where you can actually write code, right? You can do that with Azure Machine Learning Python SDK. You can definitely do that. You can set up your AutoML experiment, and you can run AutoML experiments with code, or you can use the Azure Machine Learning Studio, where you can do everything in the UI, and that's the option we will go with. So just to a little bit clarify and a little bit get into this. What are the different type of tasks that we can do with Azure AutoML? So we can do classification, regression, and time series forecasting. You're gonna need to pick one of those when you're running an AutoML experiment. So it's important to have a sense of, to have an understanding of what type of problems these different tasks involve. So classification is, for example, for fraud detection, marketing prediction. Regression is about predicting pricing. And time series forecast is, essentially forecasting. You got a time series data and you want to forecast what's going to happen in the future. And the demo that I will do today in this session will be time series forecasting. You will see where we select this in the UI. And there we go. Time for the demo. Okay. So here we are. I got an empty resource group. The first thing we're going to do, the first thing we're going to do is to create ourselves. I'm going to do everything from scratch, so don't worry. I'm going to say machine learning. I'm going to search for machine learning in the Azure portal. And come on. Okay. So this one is what we're going to pick. I'll go and select machine learning. So we're going to create a machine learning workspace for ourselves. The workspace name will be DPS test. So the workspace will need a storage account, a key vault, and application insights with it. The container registry, we're not going to create it. It will be auto-created when we do a model deployment anyways. So we don't have to do that right now. So I'm going to say review and create. And finally, I'm going to say create. So this isn't going to take a lot of time. I do have another environment that is ready to go, but I want to show you the process as well. So let me jump here. This is a full-blown environment that is created today. You can see here, I got the workspace, the key vault, the insights, the storage account. These other resources are going to be created when we deploy a model. When we create a model and deploy it, it's going to create, in this case, we're going to deploy to an ACI. We got two options. I will talk about that, but it is going to create us a container registry and then container instance where the model will be deployed and served through REST API. So the first time you create your workspace, these two resources will not be there. And let's go back. Right now, it's created the vault, storage account, and all that. The workspace is being created. So give it a minute, and it should be ready to go. As a data, okay, there we go. It's ready. Let's click on go to resource. And we're here in the machine learning resource. And from here, we're going to go right. And there's going to be a link that says Studio Web URL. So we'll click on this one, and it's going to open up a new tab, and we're going to land into the Azure Machine Learning workspace. Okay, perfect. So the data that we're going to use is going to be a CSV file that I have in here, and this is not something I created. I actually borrowed this from a Microsoft Quick Starts. So this is the file that we're going to use. So this file has some bike share rental numbers. So there's the date, the year, month, and the weather information, and then the total count of bicycles rented. So we're gonna feed in this data. We're gonna try to find the best algorithm to predict rentals for a future date. Right? That's what we're gonna do. Let me open up my notes on the second screen here because I don't want to make any mistakes, to be honest, with the parameters and stuff. I got some notes for myself. Give me a second here. Okay. Dip. Okay, so the first thing we're going to do is to go into the automated ML section. And from here, we're going to click on this new automated ML run. Okay, So let me show you that again. Automated ML, and we're in there. So the first item to do is to upload our data set. So I'm going to say create data set from local files. And I will name this bike data set. Okay. Click next. Okay, so now is the time to upload that CSV file. Let me copy the location of it and go upload files. There we go. Select the CSV. Okay, cool. We don't have to do anything other than that. I'm going to go back and take a look at my notes here just to be sure I'm not missing anything. Yep. Next. Upload completed. Come on. Okay. Good. So we can see our data. It's a delimited file, comma delimited, UTF-8. All files have the same headers. Yeah, in this case, we have only a single file anyway. Skip rows, no. That isn't on this multi-line. Okay, I guess we are safe. Next. Oh, yeah. So here we got all of the fields that are going to be used by the AutoML algorithm. Here's what we're gonna need to do though. Let me scroll down. So this casual and registered numbers, they actually sum up and go into the total count. So I'm gonna remove those. We don't need those. We're just gonna do prediction for the total count of rentals, and the rest, I guess, we can leave it as it is. Yep. Next, let me take a look at my notes, by the way. Yes, we're good. I'm not missing anything. Cool. And finally, let's double check everything that we have in here, and we're good. Click create. So this is the data source creation. So now that we created the data source, let's click on that, select that data set, and click next. The next step is going to be configuring our run. So we're going to be creating a new experiment. We're going to call this bike experiment for now. Okay, so the other thing that we're going to need to do is select the target column and then a compute cluster. Okay, so our target column in this case is going to be our prediction target column will be this count, right? That's what we do want to predict. And finally, for the compute cluster, we don't have any, so we're going to need to create one. So I'm going to say create new compute cluster. Okay. And from here, dedicated CPU, yes, so I don't need that. And this is going to be a 4-core machine. And this is the payment that we might need to do. So for the scale, we're going to decide how to scale that cluster later on. So yes, I'm going to say next. And compute cluster name, bike cluster. Okay, so minimum number of nodes, it's going to be 0, so that, you know, when we're not using this environment, there's a timer for it, and it can scale as down as, you know, 0, so that we don't pay anything. The maximum number of nodes, let's say 2. Okay, and I guess we're good. Yep. Create a cluster. So this is gonna take a moment. Let's give it a couple of seconds or so. Okay, there we go. So we got the cluster as well. So now we can click next to continue. So now here's the question, and it looks like, you know, the portal was successfully, picked time series forecast for us, which makes sense. So for the data that we have, we're gonna do time series forecasting. For the, let me see if I'm missing anything. Yeah. This is going to be the date, the time column. Yes, that is correct. We don't have any identifiers. Frequency and forecast horizon. I'm going to test the forecast horizon and say 14 days. And we don't want to go further than that. And let's see, forecast horizon is how many periods forward you would like to forecast. Okay, great. So this is in the context of AutoML. When you are sending, when you're asking for predictions to the model, you can definitely do further than that. And I guess we are good. Am I missing something? Yes. Okay. So we're going to click on this Weave additional configuration settings. There is a couple of things that I'm going to do to make things smooth. Unfortunately, we're not going to be able to dig deeper into these parameters. So those two, Weave featurization settings and additional configuration settings, these actually rely to how much machine learning experience you have. You don't have to do anything, to be honest. You might not do anything on this front. And I'm not going to do a lot of stuff, by the way. Let me see. I remember there was a couple of things that I wanted to. Yeah, I mean, this is correct. Normalized root mean squared error. This is the primary metric. We at the end of the day, we will run through a couple of different models, and we will pick the one that has the lowest normalized root mean squared error. Again, what root mean squared error means is, on a very, very high level, it's the distance between your prediction and the real values. And we want that to be at minimum, right? So explain the mass model. Okay, we might want to have that. Let's see. Yeah, there's one thing that I want to actually, we can leave it as it is. Yeah, I mean, this is where you can actually select one of these or many of these algorithms and exclude those from the AutoML process. I mean, again, this is not, we are not going to go into this. I mean, this requires an understanding of all these algorithms, and definitely, I would definitely suggest you to go and do research if you want to. But in this case, it kind of makes sense to remove this one maybe. Well, by the way, I'm not going to run this AutoML experiment because, I mean, you're going to see why. I'm not going to run this. I have another environment where this thing has already ran and we got the results. We will take a look into that. What else? I don't want to miss anything. Training job hours. Okay, this is important. So how many hours do you want to spend for this AutoML run? Because it's going to be able to run as many experiments as possible if you give it more time. The minimum amount that you can give is 30 minutes by saying this. This is the minimum that you can give. In this case, I'm not going to run this, so it doesn't really matter, but I'm going to select 30 minutes anyway. So for anything else, I mean, we can leave those settings in their defaults. Yeah, you can increase the maximum concurrent iterations if you want to, because you can have multiple runs at the same time, especially considering the fact that we increase the cluster to 2 VMs. We can definitely have more than 2, I don't know, 6 or something, and then save it. Yeah. Again, those parameters aren't a huge deal, but again, that's the area where you can, fine tune and define those, the confines of the experimentation. So at this point, if I click on finish, this experiment is going to run. It's going to provision, it's going to prep the thing, provision the cluster, and start running the experiment. Let me do that. I mean, we don't really care if it finishes or not, because like I said, I have another environment where this whole thing has already been ran yesterday night. I left it to run for 30 minutes. But let's see how this whole thing starts, because it usually takes 5 to 10 minutes to start the experiment, and then it's going to take another 30 minutes to run the whole thing. But there's only one thing that I want to show you here. That's why I'm kind of waiting for this things to start. Okay, refresh. Running, great. So submitting run to compute. So this is what that 5 to 10 minutes takes. Yeah. So it's gonna take a while. So maybe we should, yeah, jump back. Okay, so I'm gonna jump back here. So this is my other environment. When we go into AutoML, you see that there's already a run that is completed. If I go into there, it's pretty much the same screen. See, so this one is running, this one is completed. So when this is completed, we can, first of all, you can see that, you know, the best algorithm is already picked here, right? 100% sampling, the normal's root mean squared error is here. And let's switch to the modal section and see what experiments have been running. Okay, it looks like, you know, there has been a bunch of experiments that ran, and out of the, you know, the best normals root mean squared error is from sparse normalized and SG boost regressor. Yes. So, and you can see the hyperparameters here as well. And this list goes on and on. It's like 2 pages here, and this is just a 30 minutes run, right? The one thing that you can do is maybe click on this algorithm name and go into the run itself, see the hyperparameters here that's been used. Again, if you're interested into that, you can go into the metrics. You can understand what metrics have been used. And you can even go into the explanation preview and see some additional data there. Again, not the focus of our of the session for now, but know that you can actually dig deeper and understand why that particular model has been selected and how it was fine-tuned. Okay. So the thing that we usually, after this one, now that, you know, the experiment has been ran, there's a best model that is picked by the AutoML algorithm. And meanwhile, let me go back here and check, say refresh. This is still submitting to compute. Anyway, let's go back. The next step is to do a deployment because you want to serve this model, right? So we click on deploy. We give that a name, new API or something. Okay. And then, thank you. And then you select a target compute type. I don't have an AKS cluster ready to go, so I'm going to select Azure Container Instances. I'm not going to enable authentication. If we do that, it's going to give us a keys or something. So because I'm just doing this for testing, I am simply going to call new API and say deploy. So deployment will start. A Docker container image will be created and pushed into the ACI. We already have the container registry and the ACI instance. So it's going to be kind of an easy start for this round. And once the deployment has been completed, or during the deployment, you can actually go, first off, let me show you the model section. We got a single model, right, that has been picked for deployment. And then when you go into the endpoints, you're going to see that, you know, this one is right now being deployed. This is new. If I go into there, you're going to see that it's in the transitioning state, which means it's being deployed right now. There's no REST endpoint for that. But if I go back into the endpoints, and this one is the one that I deployed just an hour ago. So I'm going to select this, and it's in healthy state, and we got an endpoint for it. So we can use this endpoint to talk to the API and use our model to do predictions. So how does this API talk to? So what is the schema for the API, you might ask? So for that, we can actually look into the Swagger file. So let me click on it. And this might not really make sense to you, but let me go and Google. Oops. Come on. What's happening? Swagger visualizer. Yes. Let's go here. Oops. Where's our Swagger file? Yep. So you can see that we got a get request that responds healthy or not. And then we got a post request, and this is the body that it's expecting, right? So, okay, this doesn't make sense. We could have actually excluded this. Anyway, so season, year, month, weekday, weather information, humidity, wind speed. And if you give all that with the date, it's going to give you a prediction. Okay, I actually have one that is kind of ready to go. And here we go. This is Fiddler. And this is already targeting my scoring endpoint, as you can see here. And Yep, content type up JSON, and then there's a body that I'm sending. The date is, the 4th August of this year, and then all of this information is filled in, and I'm gonna say execute, send it to the API. Let's look at what we got back, and here we go. So the forecast is we're gonna have 2,500 bike rentals. So does that make sense? Let's look it up. So our data is kind of pretty old, by the way. I'm not sure if you noticed that when I opened up the Excel sheet, but here we go. So our data starts from 2011 and goes down to 2012, and that should be it. Oops, come on, where is it? Oh yeah, see. And if you look at 2012, you can see numbers up to 2,000, 3,000, 4,000, 5,000. Okay, it makes sense. 5,000s. Okay, cool. So a forecast of 2,500 doesn't look crazy. That looks pretty nice. And, we built an AutoML, experiment. We found the best algorithm, and then we deployed our model and we exposed our model with, with an endpoint. So, and this is as simple as that. So now let me go back to this and see if it's in health state as well. So the new one has been deployed too. So I got 2 different models in this case, which are kind of the same one. So let me refresh here too. And we're going to see that there's a new ACI, there's a new container instance. So I can keep experimenting and building new models and deploying new models as many times as I want. And here I'm going to do a refresh and see where we're at. Okay, this is in model training right now. Which means we can actually go into the models and see, hey, what's going on? And it looks like, some algorithms have been already tested. You can see the normalized run root mean square error, RMS, and we can see the child runs. Some of them have started, some of them did not, which is good. There we go, another one. So again, if you give a longer time, it's going to be able to do more experimentations with different algorithms and different hyperparameters for sure. Okay, cool. I guess we covered a nice part here with that. There we go. So this is the end of the session here. If you have any questions, feel free to ask on the platform. We do have a lot of time for Q&A here. Other than that, you can grab the slides if you want to on this link that you can see on the slides here. You can go and download the slides, and you can reach out to me on Twitter at Daron Yondem, and anything else. Daron.me is a landing page where I share different contact information as well if you're interested to get in touch in other platforms. With that, thank you for being with us and watching the session.